In the field of astrophysics, there is a great number of unknowns, and with every discovery or convincing theory seemingly comes a new set of questions to be answered. For example, we know dark matter makes up most of the universe, but we don't know what it is. Dark energy is powering the expansion of the universe, but we don't know what that is either. We don't know why very large things like black holes are governed by a different set of principles to very small things like subatomic particles. The theories of relativity and quantum mechanics make sense on their own, but not together. Now, these are puzzles above the average person's pay grade, but one unanswered question troubles thinkers of all stripes. Put simply, it is, where are all the aliens? In the history of humankind, there has not been a single confirmed contact with an extraterrestrial civilization. Only snippets of grainy footage, the odd out-of-place radio signal, and an endless string of witnesses varying in credibility. Alien probabilities. You might be tempted to say the reason for this is that aliens don't exist, but you don't have to be a dedicated conspiracy theorist to think that this explanation doesn't make a whole lot of sense either. Belief in extraterrestrials is essentially a numbers game. It's estimated that the universe is home to up to 2 trillion galaxies, each with a typical quotient of around 100 billion stars, giving a grand total of perhaps 200 sextillion, that's 200 billion trillion stars, mostly with planets orbiting them. Our own galaxy has maybe 400 billion stars, with roughly 7% being the same type as the Sun. What does that all add up to? Well, a study published in 2020 by researchers at the University of Columbia concluded that it equates to around 6 billion rocky planets orbiting Sun-like stars at a distance commensurate with life, the so-called habitable zone. That surely makes life beyond Earth a statistical probability, especially when you factor in the 1,999,999,999,999 other galaxies spinning through the wider universe. It just seems very unlikely that life formed here, but not somewhere out there, especially when you consider that right now scientists are searching for the relics of basic organisms within our own solar system. Then there's the fact that Earth is a relatively young planet compared to its spacey peers, meaning that if alien life has developed, it's probably a lot more advanced than humanity and, as likely as not, has developed communication and transportation systems far better than our own. And yet nothing. No signs, signals, or drop-ins, not a sausage. Why? The question was best summed up by the physicist Enrico Fermi, who famously asked, "Where is everybody?" during a discussion about the possibility of intelligent extraterrestrial life, and in doing so gave his name to the paradox. Lots of planets, so why no little green men? The theories. The Fermi Paradox, otherwise known as the Great Silence, has a few alien-negating explanations. One is the rare Earth hypothesis. Its proponents argue that conditions necessary for complex life are actually vanishingly rare. There might well be vast numbers of Sun-like stars and Earth-like planets orbiting them at a lifeform-generating distance, but there's just a lot more to it than that. Clever people, Peter Ward and Donald Brownlee, wrote a book on the subject, arguing that lots of factors must align in Goldilocks-like perfection to support complex life. For starters, a world must be located in a galactic habitable zone with low levels of radiation and other cosmic disturbances. Its local star must be stable with a consistent output of energy over the course of billions of years, enough for simple organisms to evolve into complex ones. The planet must have a sufficiently rich chemical mix to produce essentials like water and air, enough to engender the right sort of biochemistry. It can't be too big, or the atmosphere would be crushing, or too small, in which case an atmosphere might not form at all. It needs a consistent orbit, not straying too close or too far away from its star, and ideally it should oscillate, tilting back and forth to create seasons, which leads to the importance of a moon or moons that can hold the planet's tilt and create handy natural phenomena like sea tides. Moons are also useful for protecting planets from asteroid strikes, the like of which is thought to have annihilated the dinosaurs 66 million years ago. And let's not forget the Earth's plate tectonics, the gradual movement of large land masses which helps to recycle the planet's nutrients and regulate its climate. Put all these factors together and you're left with an uncommon, perhaps even unique, set of ingredients for habitable planets. The rare Earth hypothesis is compelling, but maybe less so with each discovery of new Earth-like planets, which has happened steadily and dependably since Ward and Brownlee published their ideas in the year 2000. Another theory, broadly referred to as the zoo hypothesis, suggests aliens are very real, but are avoiding contact with Earthlings in the same way that people living in developed societies are not allowed to go and stomp all over remote and isolated tribes. This concept was famously alluded to in the Star Trek universe, where the Prime Directive prohibits advanced civilizations from interfering with the internal machinations of species that have not yet reached a certain level of technological advancement. Aliens might be respecting our space for ethical reasons, watching us and others like us in the same way we observe protected animals in the wild. From their point of view, failing to do so could cause societal collapse and religious conflicts on Earth. Alternatively, and more insultingly, We could be the subject of scientific study, with aliens monitoring the development of pond-life species like us in real time. A third explanation is that alien technology is so advanced that we have no way of identifying or receiving it. Instead of the radio waves and other electromagnetic signals we look out for, ET might have at its disposal quantum or subspace communication, or even telepathy. They could be encoding communications so that we don't recognize them as coming from intelligent origins. Or they could have developed other ways of cloaking signals to avoid detection. Or we might just be too stupid to identify evidence that has been staring us in the face for millennia, aliens tapping their feet impatiently as we miss every opportunity to say hello. Then again, it's possible that the vast distances between stars make interstellar travel and communication incredibly challenging and time-consuming, even for highly advanced civilizations. That would slow down the process of any exoplanets contacting one another. Take the following example. Our nearest star, Proxima Centauri, has a planet, the imaginatively named Proxima Centauri b, orbiting within its habitable zone. If an alien population living there attempted to make contact with Earth via a standard radio signal, the message would take more than 4 years to reach us. Earth's first ever radio broadcast by Marconi in 1895 sent a signal into the cosmos at the speed of light. If we ignore the vagaries of the electromagnetic spectrum and interference factors, that suggests that Earth should be detectable more than 100 light years away in all directions, which sounds like a lot. But isn't. Our Milky Way galaxy, which don't forget is one of maybe 2 trillion in the universe, is on its own more than 105,000 light years across. A bit of cob maths tells us that the full spectrum of human communication covers 1,000th of a 2 trillionth of the observable universe, which is not very much of anything. This is the slow expansion hypothesis, which highlights a potential series of breaks to development. Deep space exploration of any kind probably requires vast resources, which might not be abundant enough, while the amount of effort needed to make contact just might not be worth the expenditure of time and whatever passes for money. Perhaps the saddest theory is the technological filter hypothesis, which posits that a specific, as yet unidentified, step in the process of technological development might be impossible to get past. The Great Filter is the point at which a civilization just can't go any further, meaning planets full of extraterrestrials are stuck in a place where, even with the best will in the world, they're unable to communicate or travel beyond specific distances in the necessary time frame. It's even possible that the filter is behind us, and that we uniquely somehow got through it. For example, the moment life emerged from non-life and created the primordial soup, a process known as abiogenesis, which could be a one-off. Or the filter might sit somewhere ahead of us, and we will encounter it in the fullness of time. For example, when we attempt to become a spacefaring species and science just says no. This line of thought chimes with the self-destruction theory, the worst of all ideas, in which civilizations develop in ways that are detrimental to their very survival. Their downfall could be caused by rogue artificial intelligence, overconsumption of resources, and climate change, messing around with fundamental physics, or, of course, the invention of planet-killing weaponry. Maybe all the universe's populations follow the same lemming-like trajectory, initially advancing at a healthy clip before succumbing to self-inflicted societal collapse and extinction when they balls it all up. A cheery thought. All of this is speculation, and until a spaceship lands or we get an intergalactic telegram, that's the way it's probably going to stay. For now, we are still bumping up against the same impasse Arthur C. Clarke arrived at when he made the point that 2 possibilities exist. Either we are alone in the universe, or we are not. Both are equally terrifying. That's all for now, but if you fancy a little more light-hearted science-based documentary action, then why not check out my video on the science behind the madness of crowds, or the extraordinary ascent of mesmerism. Until next time, thank you for watching.